Hi everyone, this is Mr. Hall and this is a really quick video about acids and metal carbonates. The content here is actually very similar to what I went through in a previous video on acids and metals. So if you understood the key parts of that, hopefully this will be relatively straightforward. The objectives for today are as follows. It's to state the products from the reaction between an acid and a metal carbonate, to predict the reactants or products in an acid metal carbonate reaction, and also to construct balanced symbol equations in acid metal carbonate reactions. And it's probably this final bit which many of you may find the hardest thing to do. All right, so first off, let's talk about metal carbonates. Now, metal carbonates are very different to metals. Metals, as we know, are like shiny metallic substances, solid, whereas the carbonates which they form tend to be sort of like powders. So in this example here, we've got calcium carbonate, like limestone and marble, which is a white solid like rock, which is very different to kind of calcium, which is like a shiny, quite relatively soft metal. Now, if you react these metal carbonates with an acid, you'll tend to get effervescence. And on the diagram here, you can see there's effervescence and bubbling inside this boiling tube. And then if that gas which gets produced gets bubbled into lime water, it goes cloudy, which is evidence that there's a particular gas being produced. And in that case, it's going to be carbon dioxide. You also make a salt and you also make some water in that solution as well. So slightly different to metals in that you're making three things rather than two when you react metal carbonates with acid. So when you react an acid with something like a metal carbonate and neutralize it, you make a salt. So you can class this as a neutralization reaction. And the salt is over here in our equation. And the two things you always make when you react a metal carbonate with an acid is carbon dioxide and water. And this is a good example of what we call a general equation, because as far as we're concerned, let's put general there. Like it could be any acid, it could be any metal carbonate, you're always going to make carbon dioxide, you're always going to make water, and then you're always going to make a salt, but you have to determine what the formula of the salt is and the name. Now, all these metal carbonates that we've been talking about so far, they contain the carbonate ion, which is CO3 2-, and that becomes really important later on when you have to do balanced symbol equations. So it looks a little bit like this. It's one way of thinking about it. This picture is an example of copper carbonate, where you've got the copper atom here. I've sort of drawn it in green, and then CO3, which is carbon with three options around it, forms this bond. Then it will probably most likely be like an ionic substance, but I've drawn it as a molecule just to make it easier to understand. Note that the CO3 has got a 2- charge, therefore in this case the copper must have a 2+ charge. So let's go through some examples. So I know that metal carbonates and acid always make the same three things. So if I've got zinc carbonate and sulfuric acid, I'll have to think a little bit about what the product of the name of the salt is going to be. But what I do know is I'm always going to make carbon dioxide and I'm always going to make water. So that's the first thing I do. Now, when you're determining the name of the salt, is exactly the same as what you did when you did metals and acids. The first part of the name of the salt is from the metal on the metal carbonate. Now, as you can see here, the metal in question is zinc, okay, if you can see there. Therefore, the first part of my name for my salt is zinc. The second part is from the acid. I've got sulfuric acid, therefore this must be a sulfate. Therefore, the name of my salt is zinc sulfate. Now, this is an example of a word equation. It shows us the names of the reactors and products, and it's relatively straightforward. Most of your questions will probably be around this. As you get more tougher questions and tougher papers, you might get similar equations. So let's go through some examples. So here I've got hydrochloric acid plus magnesium carbonate. Again, I'm going to start by looking at the two products I always make. Remember, I always make carbon dioxide. I always make water. So those are the first two things I write. I now need to think about the name of my salt. Now, the first part of the name of my salt is going to be based on the metal. All right. Now, if I have a look at the metal carbonate, I've got magnesium in magnesium carbonate. Therefore, that name directly goes as the first part of the name of the salt, which is magnesium. Now, the second part is depending on the acid. Now, as you can see, I've written here, hydrochloric acid forms salts called chlorides. Now, I've got hydrochloric acid here. Therefore, the second name here has to be chloride. So the name of my salt is magnesium chloride. All right, let's try another one. Here I've got sulfuric acid and magnesium carbonate. Again, the first thing I think about is what I always make. I always make carbon dioxide. I always make water. I now need to think of the name of my salt. The first part of the name of my salt is based on the metal. And if I have a look at the metal here, I've got magnesium in the magnesium carbonate. Therefore, the first part of my name is magnesium. The second part of my name is based on the acid. I've got sulfuric acid here. Therefore, I have to make, so it's from the acid, I have to make a sulfate. So it's magnesium sulfate. That is the name of my salt. Okay, great. So if we kind of look at a few predictions of just how to do this. Now, I'm going to be like extremely lazy here, and this might be a good opportunity for you to pause it and have a go before we continue. But the first thing I'd always remember if I've got carbonates is I always have carbon dioxide. I'm just going to write CO2 here just because I'm being, I just want to do this quickly and lazily. But obviously, if you're doing a word equation, you'd write carbon dioxide in words. So I've got carbon dioxide in all of them, and I've also got water in all of them. That I cannot dispute because anytime I react a metal carbonate with an acid, I always make these two products. The carbon dioxide is the gas that goes into the atmosphere, water stays in solution, dilutes it a little bit. So the tricky thing is the name of the salt. Now remember, the first part of the name of your salt is always going to be your metal. So the first part of the name is always going to be the metal part. So here it's going to be magnesium something. This is going to be sodium something. This is going to be copper something. This is zinc something. And this is iron something. Now let's have a look at the acid. For the first one, sulfuric acid. So this is magnesium sulfate. Okay, because sulfuric acid makes sulfates. Notice I'm using F rather than pH. I think UPAC, which is like this big sort of organization, they've said that you have to use Fs rather than pH when doing spelling. I've used pH here just because I've been a bit sloppy, but now you know. Here I've got sodium carbonate and hydrochloric acid. That makes a chloride, so it's sodium chloride, which is common salt. Here I've got copper carbonate and nitric acid. Now, I haven't mentioned this before, but if you have nitric acid, you make a nitrate. Okay, so this will be copper nitrate, like so, plus the other two things we always make. Here we've got zinc carbonate plus sulfuric acid, so that would be zinc sulfate. Again, I'm using an F because I should. And then finally, iron carbonate plus nitric acid makes iron nitrate. Okay, so you can see that actually constructing these word equations isn't that tough. Doing the symbol equations is a lot tougher. So here I've got magnesium carbonate plus sulfuric acid making magnesium sulfate plus carbon dioxide plus water. Now, here I've got the symbols and the formulae for the acids. I've mentioned this before, but it's well within your best interests to learn the formulae of the acid. Sulfuric acid is H2SO4. That's something which you should really remember when you go into an exam. Now, thinking of the formula of the carbonates is a bit harder. Now, here we've got magnesium carbonate. Now, if you think about it, let's see what else I've got coming up here. Carbonate has the charge 2-, and magnesium has the charge 2+ when it's an ion because it's in group 2. So you can see that because this is 2+ and this is 2-, if you put it sort of on a seesaw, the different charges, you've got 2+ against 2-, which balance out. So you only need one of each in order to have a balanced ionic substance, so it's MgCO3. Now, when you're thinking of what the actual products are going to be in this reaction, I'm just going to change the pen color to red. There we go. You have to, again, think about what the formulae is of the different ions. Now, for magnesium sulfate, well, we can do carbon dioxide and water first of all, because that's easy. So CO2 plus H2O. But for magnesium sulfate, it's a bit harder, because magnesium sulfate, I've got magnesium, and because it's in group 2, I know it's got to be 2+. Now, the sulfate ion is SO4 2-. And one way of remembering it is by looking at that formula and thinking, well, if I've got 2 hydrogens and each one is 1+, that means in total the hydrogens are 2+, therefore my sulfate ion, the SO4, has to be 2-. Now, if you look at it, you'll notice that they're both equal charges, 2+ and 2-. So if you put it on like a little seesaw, like I showed you before, you've got 2 pluses on this side, and you've got 2 minuses on this side, which balance out. So you only need one of each to make this work. So the overall formula would be MgSO4. You wouldn't have to write those charges in. That's not necessary. So the formula are MgSO4 plus CO2 plus H2O. This is probably the toughest. This is the toughest thing that you have to do in any exam, because you're expected to kind of work out the ionic formulae, and you're sometimes expected to balance as well. And some of the tough ones will need you to do that. So these can be quite tough. We have a look at this example. I've got sulfuric acid plus sodium carbonate. Now, first off, sulfuric acid is, as we remember, H2SO4. Actually, Joe, I might actually use yellow pen for this just to make it a bit easier to see. There we go. Ooh. There we have it. Right, so I know that sulfuric acid is H2SO4. The tricky bit is sodium carbonate, and that's where you have to be quite sharp about your ability to work out ionic formulae. Now, sodium is in group 1, so if it forms an ion in an ionic compound, it's going to be Na+. I'm going to write it at the bottom here. However, carbonate, as we remember from what I showed you earlier in this video, is CO3 2 minus. Now, if I put that on a little seesaw, a very straight seesaw, I've got the positive from sodium and the 2 negatives from the carbonate. So in order to make the charges balance out, because you need balanced charges in ionic substances, I need 2 sodiums. So I need 2 sodiums for 1 carbonate. So I need 2 of these. Therefore, my formula is Na2CO3. Now, to work out the products, the best way to start really is by doing the ones that we know, which is carbon dioxide plus H2O. The trickier bit is working out the formula for sodium sulfate. Now, if you remember what I mentioned just earlier, sodium has got a charge of +1, and sulfate, if you remember, has got a charge of 2 minus. There we go. Now, again, if I do a little seesaw, my sodium is 1 plus, my sulfate is 2 minus. So the only way of getting this balanced is by having another sodium ion, which means another Na plus. Therefore, the formula has to be Na2SO4. And then the final thing you have to do is to balance it out. And if you look carefully, you'll notice that actually the number of atoms on the left and the right are balanced. I won't go through that now. I'll leave that to you to do, but it is balanced. And then let's do one more example. So here I've got hydrochloric acid plus calcium carbonate. Now, hydrochloric acid is HCl. Again, really, really beneficial for you to remember that. Now, calcium carbonate, a bit trickier. Calcium is in group 2, so it's Ca2+. Carbonate, as we know from earlier, is CO3 2 minus. If I do my little seesaw to work out the number of charges either side, calcium is 2 plus, CO3 is 2 minus, and you should see that they have the same number of plus and minus either side. Therefore, you only need one of each to make this balance. Therefore, the formula is CaCO3. Now, in order to work out the formula for these, again, I'm going to start with what I know. I know carbon dioxide is CO2. I know water is H2O. The tricky bit is the formula for calcium chloride. Again, let's go to what we know. Calcium has got a charge of 2 plus. Now, chlorine is in group 7. It needs 1 electron to have a full outer shell. So if it becomes an ion, it will have a charge of -1. Therefore, the ion is Cl-. Now, if I put this on a little seesaw like I've done in previous examples, I've got the 2 plus from calcium, and I've got the 1 from chlorine. Now you'll see that there's more pluses than negatives on one side compared to the other. So in order to make them balance out, I need another negative, which means another chloride ion. Now that means I've got 2 of these, but only 1 of these. Therefore, my formula has to be CaCl2. Now, if you double check balancing, you'll notice that you've got 2 hydrogens here, but only 1 here on the left, and you've got 2 chlorines on the right, but only 1 on the left. So to balance it out, I need to put 2 there. Obviously, when you're doing it, you might want to sort of be a bit more careful with your balancing just to make sure you get it right. And that's it. So I hope this video on acids and metal carbonates has been helpful, and best of luck with any questions you have on this.